Hello, Precalculus kids. This is Miss Lefort, and today we are going to expand our solving equations, the exponential equations. Before, we looked at the exponential equations that were able to get to the same base. This time, it won't be that easy. So there is another strategy that we're going to learn. So we're going to just start with example 1 and show you how to do this. So since 3 and 80 cannot go to the same base, so that means we're going to need to log both sides. So I'm going to do log 3 to the x equal to log 80. So whatever you do to one side of the equation, you got to do to the other. Now, because we took the log of both sides, we can now use those log properties. Remember that x can now come down to the front. So this is x times log 3 equal to log 80. And now to get x by itself, we just divide by log 3. So if we're looking for an exact answer, that would be it. We could also write it as log base 3 of 80. Remember, that's just another way of writing it. And then if you plug it in your calculator to get an approximate, and I do want you to try this to make sure you can get the right answer, that would be 39887. Okay, so that's our approximate answer. Now number 2, notice this one's got e. So whenever you have e, you want to use ln. So we have ln e to the x equal to ln of 140. So now we use our property. Remember that x can go down to the front. So this is x times ln e equal to ln 140. And I'm not sure if you recognize this or not, but ln e is equal to 1. So I'm going to go ahead and mark that, okay? So this ln e, all that is 1. That represents 1. And you're going to learn that. And you can plug it in your calculator if you need to. But it represents 1. So really, we just have x equal to ln of 140. So that would be our exact answer. And if we plug that in the calculator to get an approximate answer, that's 4.9416. Now let's take a look at the next one, okay? And if you want to try this one on your own and pause the video and do it and check it, make sure you got it right, that'd be amazing. I would absolutely love that. But I'm going to keep going, so if you want to pause it, pause it. If not, just keep going right with me. Notice 5 and 18 doesn't have anything, like we can't go to the same base. So I'm going to take the log of both sides. Now I'm going to bring that exponent down. And notice when I bring this exponent down, that's a binomial. So I have to put parentheses around it, because both of those would be times log, x plus 1, not just the 1 or not just the x. And at this point, I just want to isolate the x. So I could distribute the log 5 in, but I really don't need to. I can actually just divide by log 5 on both sides now. And now subtract the 1. So my exact answer would be log 18 divided by log 5 minus 1. And then if you plug that in your calculator and get an approximate answer, that is 0.7959. And again, just make sure you can do that. And if you have trouble with that, just let me know in class, and I'll certainly show you how to get the right answer there. All right, notice how these are getting a little bit trickier. Not only do we have a binomial exponent, we have a fraction involved. But basically, you're doing the same steps. So log both sides. So log of 1/3 to the 2x minus 5 power equal to log of 120. Now we can use that property, bring it down, the exponent down. And again, all we're doing is trying to get x by itself. So you remember, this is times. So I'm just go ahead and divide by the log of 1/3. So I probably should have put my pen at a little bit smaller writing to make it fit better. But hopefully this will work. Now we want to get x by itself, so we're going to add the 5 to both sides first and then divide by 2. So I'm going to put this in the same step since I'm running out of room here on this paper. Log 120 divided by log of 1/3. I'm going to add 5 to whatever I get there. And then this whole thing, I'm going to divide by 2. So I'm just going to write it as times a half since I'm running out of room. So all of that, and you got to be careful how you plug that in your calculator to get the right answer. All that is the exact answer. This is your approximate. So I would say, pause, make sure you can plug that in, get the right answer, just so you know how to get it. All right, so now we're on to number 5. Now, number 5, it's starting to get a little trickier here because now, instead of just having one item on each side, now we have more than one item. So first step is to minus that 25 to move it over. You've got to isolate that term that has the exponent before you can do the log. So this would be 3 to the, actually, you know what? No, I can keep going. 3 to the EX equal to 108 minus 25, that is 83. So now that I have that term isolated, now I can log both sides. Now because it's E, I'm using ln. Now I can bring that exponent down. So it's 3x times ln E. Ln E is 1, so I'm not even going to worry about writing it. And then that's ln 83. So now we can divide by 3 and get our answer. So that is the exact answer. The approximate, if you plug this in your calculator, should be 1.4729. Again, just be careful how you plug it in. Make sure you're taking the time to do that. And if you have questions, just ask me in class. I'll be glad to help you out. Now notice on number 6, okay, so this one has a little bit more going on too. It is -2 times 8 to a power. So we are going to divide by -2 on both sides. So if I divide by -2, then this gives me 25 over here. Now it looks like what we've done before already. So we can take the log of both sides. And I just want to let you know, you can do log or ln on these. Okay, so ln, the one with E, you need ln, but everything else you could do log or ln. And since I did log on all the rest of them, I think I might do ln just to show you it is this, you will get the same thing. Okay, so if you want to use log instead of ln here, that's totally fine. So once we do the log on both sides, we can bring that exponent down. And then isolate the x. So I'm going to divide by the natural log of 8. So 4 minus x would be equal to ln 25 over ln 8. And now we just need to isolate x. So instead of subtracting the 4 and then dividing by -1, I'm just going to move or subtract the ln of 25 over ln 8 and then add the x to the other side. It's the same thing, right? So that is your exact answer. And if you plug this in your calculator, you should get this as your approximate. Now, you might want to try it with the logs instead of ln's. As long as you're using the same thing on the top and bottom of that fraction, it doesn't matter if you put log or if you put ln, either one. All right, so now we're off to the second page. All right, so this one, they get harder as they go through here, so we want to make sure we have it. Oh my goodness, I just put a stray mark right here. Okay, I'm still learning this program, y'all. I'm trying my best to get this to be time efficient and still get the point across. So, oh goodness, I did it again. So just bear with me a sec. Okay, so on this one, number 7, let's see, we have to isolate the term that has that exponent. So we're going to add the 1 first. So that would give us 2/3 times this 2 with the exponent. Over here, if I add 1, that's 42. Okay, so get rid of the exponent. We're going to multiply by the reciprocal. Let me change a color. So I'm going to multiply by 3 over 2. Okay, because that's how we can get this to cancel and be 1. So over here, I just have that 2 to the x minus 6 power. Over here, let's see, this is like over 1, so the 2 cancels with that. That's 21. 21 times 3 is 63. Now, if you don't believe me, you can check it on a calculator. All right, so now we have it where the thing is isolated, so we can now take the log of both sides. bring the exponent down. Hopefully by now you're starting to see these procedures are the same in every one. To isolate the x, we can divide by log 2. And then add the 6 to both sides to get x by itself. So some of them aren't too bad. It's just new for you. Okay, so there's our exact answer. And our approximate, once you plug that in the calculator, should be 11.9773. So just double check you can get that value. Let's see, I'm gonna just keep going. So if at any point you wanna pause it and try some of these on your own, you are more than welcome to. That'd probably be a good idea. And you can just fast forward to the end to get to where the answers are popping up. So you don't have to watch all of it if you don't need it. All right, so let's see, number 8. First step, minus the 9 on both sides. So I'll go ahead and bring this down. And if I subtract 9, that gives me negative 64. Next step, divide by the negative 2. So that's what, 32? Now this one is where we could log both sides. But I want you to see that sometimes, like on this one, you can get the same base. So if you recognize that you can get the same base, then, use it instead of the logs. So this one happens to be one you can. And now on the test, they're going to be all mixed up. So you're going to want to look for the same base because a lot of times that's easier. But we can get the same base because I'm recognizing this is 2 squared. And this is 2 to the 5th. So now I can just use my power, my one-to-one property here and solve. So it makes it much easier. Because if I can get the same base, then I just know 4x plus 14 has to equal 5. So 4x is equal to, what is that, negative 9. So x is negative 9/4. So you don't even need a calculator on that one. But if you did want to get a decimal, that's what, negative 2.25. Now you could still do the log on both sides. It's going to give you the same exact thing. All right, so now we're going to go on to the hard ones, okay? So these last 4 are the more complicated ones, and yes, you are 100% going to see this on your test. So I want to make sure you know how to do it. So I'm going to put a little star by these, because, you're going to have a lot of stuff on your test. Oops, I thought I was on pen, but no, I was on highlighter, okay? You're definitely going to have one like these types of questions, okay? So make sure you know how to do it. What makes this challenging is that there's variables in 2 places. So I'm going to walk you right through it. So on number 9, let's see. Notice 2 and 3 don't have the same base, can't get the same base. So I am going to log both sides of this equation. All right, so just like before, now we can use our log property, bring that exponent down. And because it's a binomial, I want to bring it down with the parentheses, because that matters. Okay, so make sure you do that. Now notice here, we usually would divide by log of 2, but the issue is we've got x in more than one place, so we really can't do that just yet. So the key here is to distribute those logs into it, because we want to isolate the x's and get the x's together. So this is x times log 2 plus 5 log 2 equal to x times log 3 minus 2 log 3. So notice I distributed it in, got rid of the parentheses. Now every term that has an x needs to go to one side of the equal sign, and every term that doesn't have an x needs to go to the other. And it doesn't matter which side you put it, just switch it around. So let's see, I'm going to do x log 2. I'm going to subtract the x log 3 on this side. And then over here, I'm going to subtract that 5 log 2. And I already got a minus 2 log 3. Okay, so every term that had an x went on the same side. So now I'm going to factor out a GCF of x. You see how they both terms have an x? So I'm going to take it out and put the x in the front. Okay, so if I factor it out, I get log 2 minus log 3. Over here, everything stays the same, just bringing it down. Sorry, my handwriting is not better. It's kind of hard using this program. I'm used to Notability. Anyway, so now I can divide by that chunk. So x would be equal to negative 5 log 2 minus 2 log 3 over, the whole thing is over log 2 minus log 3. So that, my friends, is the exact answer. Now, if you had went the other way, every term would be a different sign, but that's absolutely okay. It's going to give you the same approximation, the same answer, okay? So that would be 13.97. So again, pause it, make sure you can get that answer and get those steps down. Now we're going to keep going. I'm going to go through all of these. You can pause it and just go to the answers of what you need if you don't need to see all of them. But basically, it's the same process on all of these. So number 10. Okay, so here 5 and 8 have nothing in common. So we're going to log both sides. All right. Now we're going to use the property that says we can bring this down. It's one of the properties of logarithms. Now, because I have x in more than one place, I got to distribute in the logs on both sides. So 2x log 8 minus 1 log 8. Notice I don't have to put a 1 with it. I can, but I don't need to. X log 5 plus 3 log 5. All right, so every term that has x needs to go on the same side. So I already have this one here, so I'm going to subtract the x log 5 on this side. I'm going to add the log 8 on that side. Now, the key thing is factor out the GCF, which is x. Lots of writing on these, I know. All right, and now just divide by that chunk. Okay, so log 8 plus 3 log 5 divided by 2. Oops, look at me. I know if I'd have been in the classroom, you'd have showed me, right? That x shouldn't be there. My bad. I just caught it, so there we go. 2 log 8 minus log 5. That's your exact answer. And if we plug this in our calculator, you should get 2.71. All righty, 2 more left. We got this. All right, I'm going to just keep going. So if you want to try these on your own, pause the video, try it, and just check and see if you got your answers right. Okay, so let's see this one. Log both sides. Log 4. Log 11. Because that's what allows us to bring these exponents down. Now distribute in the log 4, or the log 4 to both of these terms. Over here, we're distributing in the log 11. Move every term with a log to the same side. With an x to the same side. X log 4 minus 3x log 11. Over here, I'm going to add the 3 log 4. All right, now we're going to factor out the x that they have in common, because that's what I need the x to be by itself. Lots of writing on this one, isn't it? We're almost done though, guys. Alrighty, so divide by that chunk that's by the x, and then we have an answer. There we go. And again, in the calculator, the approximate answer is negative 1.54. So yes, on the test, you're going to need to give me both. I'm going to be looking at your work. I'm going to be looking at all your steps and everything. So put it all. And the last one that we're doing together today is this one. So let's get it done. Okay, so log 9, here log 2. Oh, this one actually might not be as bad because there's not a binomial exponent on that first bit. But we do bring it down to the front. We just won't have to distribute that in since there's not two terms there. So that's kind of nice. It does save us a little bit of work. Now we do have an x in two places, so we still got to get them all to the same side. So I am going to, I guess it doesn't really matter which way I go here, but I'm going to subtract the 4 log 2 over here and add the 2x log 9, okay, to that side, just so I wouldn't have negatives all the way, across the board with the x. I don't want negatives with the x. Not that it matters, because it's going to give me the same answer anyway. All right, so on this one, I'm going to factor out the x that they have in common to isolate the x. And then divide by that chunk to get the x by itself. And then we're basically done, y'all. How awesome is that? Now plug it in your calculator. Make sure you're getting the right answer. And that's negative 0.35 about. Alrighty, so we are done the lesson. So let me know if you've got questions when we get back to school.